Look at any world map and run your finger across the Indian Ocean. It looks like a vast, empty blue stretch, a place where the planet simply gave up trying to make land and surrendered the space to water. But if you look 2,000 kilometers off the coast of Africa, you'll find Mauritius. This island is geologically young, formed a mere 8 to 9 million years ago by localized volcanic activity. Over 1 million tourists walk these beaches every year. They come for the white sand and turquoise water, unaware that they are standing on the surface of a much older mystery. The map shows only a simple surface. Kilometer after kilometer of cold ocean water hides a massive ancient secret lurking directly underneath the seafloor. In 2013, a team of geologists studying the island's volcanic origins began analyzing the mineral composition of the beach sand on Mauritius. Mixed among the young volcanic minerals were tiny crystals called zircon. Zircon is a geologist's most reliable witness. It is incredibly durable, surviving heat and pressure that would destroy almost any other mineral. When the team dated these crystals, they found a startling discrepancy. These specific grains were up to 3 billion years old. Young volcanic rock cannot produce 3 billion-year-old crystals. For those minerals to end up on a beach in Mauritius, the young magma must have passed through and picked up pieces of an ancient continental crust hidden deep below. While the zircons were suggestive, skeptics argued they could have been carried there by ocean currents. To prove a continent truly existed, scientists needed to see it. They used a technique called seismic reflection, essentially a planetary ultrasound. Sending sound waves into the Earth to measure how they bounce off rock layers determines what the crust is made of. Beneath the dense basalt, data revealed a massive rock layer with the signature of continental crust, stretching across hundreds of thousands of square kilometers. The seismic data confirmed what the sand suggested. A slab of ancient continental crust, perhaps 3 billion years old, was sitting beneath the Indian Ocean, a lost continent named Mauritia. To find where Mauritia came from, you have to go back 160 million years, when the Earth's landmasses were fused into the supercontinent of Gondwana. Violent geological forces eventually tore Gondwana apart. As massive blocks of India and Madagascar separated, the crust between them was pulled and thinned. During this split, a fragment of crust snapped off and became isolated. Mauritia was born as a piece of continental shrapnel caught in a massive tectonic rift. This microcontinent was once dry land, a green, mountainous bridge that allowed species to move between India and Madagascar before the ocean grew too wide to cross. The destruction of Mauritia began with fire from below. A mantle plume, a column of superheated rock, now known as the Réunion hotspot, punched through the crust like a blowtorch. Roughly 66 million years ago, this same hotspot created the Deccan Traps in India, one of the largest volcanic events in history, and a likely contributor to the extinction of the dinosaurs. As Mauritia drifted over this hotspot, it was buried under millions of tons of lava. The weight of the new volcanic rock, combined with the thinned, weakened crust, began to push the land downward. It was an agonizingly slow drowning. Coastlines moved inward, hills became islands, and eventually the last peaks of Mauritia slipped beneath the waves. It didn't just disappear, it was overwhelmed by the Earth's interior and erased from the surface. The discovery of Mauritia shows that continental breakup is a messy process. When supercontinentals shatter, they leave behind massive amounts of rubble. The ocean floor is littered with these ghosts. There is Zealandia near Australia, the granite islands of the Seychelles, and fragments of the Jan Mayen microcontinent in the North Atlantic. These discoveries challenge the clean, simplified models of plate tectonics we see in textbooks. The Earth's crust is far more crowded with hidden ancient fragments than we once believed. The vast blue spaces on our maps mask a complex landscape. Beneath the surface, the oceans hold the shattered, drowned remains of dozens of ancient worlds. We build our cities and draw our borders on land we think of as permanent. We treat the continents as the fixed stage of human history. Mauritia reminds us that the land is not solid. It is a thin skin floating on a churning interior. Over geological time, mountains drift, collide, and sink. 60 million years from now, the land you stand on today may be at the bottom of an ocean, buried under kilometers of volcanic rock and water. A future geologist might look at the rocks of that distant world and find a thin layer of chemicals or microplastics, the only physical signature our civilization ever existed. They will look at their maps and wonder about us, exactly as we now wonder about Mauritia, hidden, silent, and forgotten beneath the waves.